Math is a wonderful thing. Math is a really cool thing.
Solving inequalities using factoring. Solving inequalities involves obtaining all values of the unknown variable x for which the inequality is true. Inequalities come in different forms of functions, and in this lesson we will be solving linear inequalities, factorable quadratic inequalities, and factorable cubic inequalities. The prerequisites for this lesson include understanding greater than, less than symbols and how to place these on a number line, the ability to factor, zero product property, long division using a cubic function, and placing solutions in interval form. Solving linear inequalities. Solve the inequality and place the solution on a number line. Solve by isolating for the unknown variable x. -8 plus 4x is greater than or equal to 16. Isolate x by adding 8 to the other side. Divide both sides by 4 to solve for x. Place the solution of x is less than or equal to 6 on a number line. Solving factorable inequalities. Begin by subtracting 2x from both sides to create a quadratic equation. Factor the function to solve for x. Then use zero product property. Place the solutions in a sign analysis chart, find test values, and calculate the sign of the test value for x in the function. Turn the solutions for x into 5 different intervals of x is less than -1, x equals -1, -1 is less than x, which is less than 3, x equals 3, and x is greater than 3. Find test values fitting within these intervals. Place the test values into the factored version of the function to find the values of x that are negative in order to make the inequality true. The interval of -1 is less than x, which is less than 3, makes the original inequality true because it is less than 0. Place the solution on a number line. Let B represent the factors of the constant -3. These factors include 1, -1, 3, and -3. Find a factor for x that makes the function equal to 0. -1 subbed in makes the function equal to 0. This means -1 is a factor. Used with zero product property, x plus 1 is the factor to divide by. Use long division to create a quadratic rather than a cubic function. 2x cubed minus 3x squared minus 8x minus 3 divided by x plus 1 equals 2x squared minus 5x minus 3. Factor the quadratic function and use zero product property to determine solutions for x, which become x equals -1, x equals -1/2, and x equals 3. Place the intervals of x is less than -1, x equals -1, -1 is less than x, which is less than -1/2, x equals -1/2, -1/2 is less than x, which is less than 3, x equals 3, x is greater than 3 in a sign analysis chart. Find test values and calculate the sign of the test value for x in the function. The intervals of x is less than -1 and -1/2 is less than x, which is less than 3, are negative, making the inequality true. Place the solution in interval form and on a number line. Displayed were 3 examples of solving factorable inequalities, including solving linear inequalities by isolating for the unknown variable x, solving factorable inequalities by inserting values of x found from factoring into a sign analysis chart, determining which interval makes the function true, and a cubic inequality, which involved long division and factoring to determine the values of x to be placed in a sign analysis chart. The intervals making the inequality true were then placed in interval form and on a number line. By studying the examples displayed, there should be an understanding of how to solve factorable inequalities. For extra practice problems, go to www.education.com, which provides 25 examples of sample questions.
So get off your ass, let's do some math, 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 math.